Everyone, welcome to my channel urmishaeduworld. Today's video is in the continuation of the previous two videos which are on Python operators, and today in this video we are going to explore on membership operators and few other. So what is membership operator? So first of all, membership itself says something related to a members. So members, which means this apple, mango, oranges, kiwi, they are actually the members. So if I want to say something that whether this member belongs to this variable X, so in such scenarios, you can use this membership operator to check whether that belongs to this sequence of objects, a sequence of values, or sequence of the members. Then for such scenarios, you can use the membership operator. This works for lists, tuples, sets, because in all that they are always been in a sequence, in a numbers. So I mean numbers as in they are a lot of values will be there, so you need to see or to check whether they are belong to this or whether they are in this particular set, this particular tuple, or this particular list. So just for checking purpose you can use this membership operator. One thing you need to keep in mind that if you work on arithmetic or bitwise operator, they will get you some values in numbers. But if you work on membership operator or any logical operator, identical operators, then conditional operators, any of those which are related to giving you the output something in a yes or no, then they are always going to generate something on the basis of boolean data type where you will get true or false. So the point is whether this condition satisfy or not, that is all about this operator going to work. So here as well in membership operator, we are going to check whether the member belongs to this particular variable. Then if yes, then true. If no, then false. So let's see with one scenario. Let's say I write here banana. As you can see, banana is not there in the list. But if I want to check whether they are in the list, I would simply write the member and then write in. In is the operator that works here. And X is the variable that itself. Now run this cell. You'll get it false because that banana does not belong to this list. So if I say kiwi in X, in that case you will get it true because kiwi actually there in this list. So apart from this in, there is one more membership operator that is not in. So let's say if I write again kiwi not in X. So not in is exactly the opposite of the in operator that works. So if I say kiwi not in X, so that is does kiwi in does kiwi is not in X? That's how the question. So we would have got false because it's there in this X. So that's how this membership operator works. Now we'll see the another operator, that is a bitwise operator. So bitwise operator word itself says something in a bit by bit. So here this operator is different, way different. It's working with the binary numbers. So any decimal numbers first is need to be converted into a binary language, and then you can probably work on the operation and how the values you will get. So operations there are similar to the what we do in the decimal, but the point is it's doing bit by bit. So that is the difference in bitwise operator. So as you can see, I have just an example. I've put it out here, that binary and decimal. So everything, if you see, the range is between 128, 64, 32, 16, 8, 4, 2, 1. So that's how the decimal number have been arranged in this 8 byte. Okay. So individual byte by byte, it's all going to get analyzed. So let's say if I want to create a decimal number which is equivalent to 101. So in that scenario, I need to uh, choose those numbers which will on addition get me the 101. So as here 101 is, you can not have 128 because it's beyond 101. So I will select 0 or say no for that. If I am 101, 64 is smaller than that, so I will give it 1 for that because yes, I need, so out of 101 now, 64 I have taken. Next is 32. on addition of these two numbers, I'll get something which is 96, which is again lower than 101. So I will have 32, yes. Now, if I add 16, then it will add up way beyond this 101. So I will put it no and it give it 0. 8 as well, because now the next point it's just need I 5 more. So 8 as well, 0. 4, yes, because we need 5. So in that case, we will give it 1. And for 2, 0, because we need 5. So overall 5. So it's just 1 I need now. So I'll give it 1 for 1. So rest of the other numbers which we don't need, we will give it 0. So that's how. So at the end, the binary is this, which is on which this whole calculation is going to get performed. So now let's see how this x and y variables where the value has been assigned 5 and 9 will work in this way. Okay. Now here on the bitwise operator, we can perform the AND operation, OR operation, XOR, NOT, and this 0 filling the left side and signing the right, shift and all that. So we can perform the shift operation as well. So let's see one by one how all this operation works. So before we moving all this, we need to first understand what the X value, if I move something in a decimal, it will relate. If I say I want something as in 5, so how the decimal will take as in this format? For creating 5, I don't need 128, so I will give it 0, 64 0, 32 0, 16 0, because they are way more great, big number than 5. 8 definitely 0, because I need something which is 5. I don't want 8 is again a big number. 4, yes, 1, 2, 0, 1, 1. So that's how where I need. So because in total I should get something 4 plus 1, it's now giving me 5. Similarly, I created for 9. I have to put 0, 0, 0 over here. But for 8, 1, 4, 0, 2, 0, and for 1, 1. So that's how I clearly define this for x and y. This is my x, okay, and this is my y. Now on the top, what I need to perform here is an AND operation. So what AND operation? AND operation and the previous operator I have already explained you that whenever bit by bit, if you are checking, so you have to calculate everything vertically for all the respective ones. So in that case, if both the values are 0, then I will give it 0. But if both the values are 1, again 1. But in case when there is 1 0, another one is 1, then in that case the AND operation will give it 0, because I need both the condition to be satisfied should be same. Okay. So let's see. If I put this AND operation and say this, then I'll calculate. This will give me 0. This will also give me 0, because 0, 0, 0, 0, 0 AND operation will give me 0. Again, this has 0. 1, 0, 0. 1, 0, 0. 0, 0, 0. And what about this 1, 1? I'll get it 1. So if I put it this in a decimal terms, then I'll get something which is equal to 1. So now let's run this cell. Oh, what is y? Alright, let's run this first and then now run this cell. It is giving me 1. So that's how you are getting this AND operation as x and y by this way, that whenever you do AND operation, you have to go in bit by bit in the terms of 128, 64, 32, 1, 16, 8, 4, 2, 1. So that is the code actually to understand or to convert anything in binary to decimal, decimal to binary. Okay. Now this is an ampersand sign for AND. Okay. And here there is a vertical bar that is for OR operation. So OR operation, again, if you want to do OR, then in that case either one value is 1. It's between 0 and 1. If anything is 1, then it gives you the value as 1. Okay. In the rest of the case, if 0, 0, then 0. But otherwise, in any scenario, it will give you the true value as a 1. So let's say for this condition, if I am calculating OR operation, then this will going to give me 0, 0, 0, 0, 0, 0, 0, again 0, 0, 0, this is also 0, 0, 0. And what about 0, 1, 1, 1, 0, 1, 0, 0, 0, and this is 1 1 1. If you calculate this, then this stands for 8, 8 plus 4, 4 plus 1, so that is 13. Okay, so let's see. Yes, we are getting 13. Now there comes an XOR which is having a power sign, something. So XOR is like if there is a same value, it will going to give us 0. But if there is a different value, then it will give us 1. So let's see what it gives here. It gives me 12. So how I get this? Let's see within here only. Same example. 0 0, it will give us 0. 0 0, again 0. 0 0, 0, again 0. Then 0 1, both are different. So as I said, if both are different, then 1. 1 0, 1. 0 0, 0, and 0 1 1, again 0. So in terms 8 plus 4, which is equal to what? 12. So that's how we got a 12. Okay, so this is what you can have for AND or XOR. Now we'll see about this NOT. But before we jump to the NOT, I would like to first understand about this uh, shifting towards the left and shifting towards the right. Here is 5, which is equal to this as per the numbers, right? Oh, there is one more we need. That is here 0 to give it all 4. Yeah, that's what, right? 0 0. Okay, all 8 bytes is there. Now shift 0 fill left side. This arrow, when you arrow and the arrow points towards the X and to the left side, and arrow is pointing towards the left side, okay, and there is 2 here which says that 2 times shifting the position. So how this works? So when you shift anything 2 times over to the left, which means whatever the value is here, you should shift it to by one place. Okay, so anything is there, you need to shift it by one place. So this 0 will change it to this 0. That's how. So at the end, what you will get, run this cell, you will get something as in 20. So how this works? Oh, this is just a 4, not 5. Let me change this. Okay, let me first change this to, this is 1. Then and then we can have this, sorry. So how I can change this to the 2 position over to the left? So what happens is, this will shift to one place here, and this will shift to the one place more over here. And what about these 2 places? So what happens, this will be removed and here 2 zeros will get added. So what could be the new number? It would be 0 0 0. No, it would be, one second, need to write it from here, from the right side. So this will becomes 2 0. Okay, so now whatever the value was here, it was initially, so 2 zeros will be added. So as per that, this becomes 1, this becomes 0, and this position becomes 1. The rest of them are 0 0 and 0. That's how. Okay, if you discard these two, if you discard these two and now shift every position by 2 times and adding 0 on the right side, so that's what it is having this. So now understand, with 128, 64, 32, 16. So this is the 16th place. So as per the decimal, this will give you 16. This is 8, 4, 2, and this is 1. So in that scenario, I can have and consider this 16 plus 4 is 20. So that is what you get by shifting 2 bits by 0 adding, and this is how 0 fills. So this is what we call a left shift. Okay, so now understand with the right shift as well. Okay, let me clear this, and now again let me write this 5 in the terms of. So now understanding this right shift, once run this, you will get something as in 1. So how does right shift work? For shifting the right, you need to shift over this 2 places, because here again I have mentioned as 2 here. So the point is 2 zeros has to be added from this place. So how I can do, if I place somewhere here the 2 zeros, and now giving these zeros onwards, so this 2 zeros. Okay, now the next 2 more zeros, till this you have reached. Now what about these 0? So this will be 0 and 1. So here my point is, you need to discard these two. These two will be discarded because we are shifting towards the right. So while shifting towards the right, the 0 has been added, two zeros will be added, this place will be shifted. Okay, so that's how you can have. So if you consider this by 128, 64, 32, 16, 8, 4, 2, 1, in that case only 1 is there. So that's how we get the right shift as in 1. So anyway, whenever you are doing this right shift or left shift, you need to add zeros. If you are doing the left shift, then add zeros on the right side, and if you are doing the right shift, then add zeros in the left part. So that's how you can do the shifting. Now the last part which is left is to perform this not operation. So what this not operator here is with the tilde sign, tilde x. So let's see what is giving here the value for x. X is 5, so this is giving -6. So let's see how we are getting this -6. Okay, to perform this, we need to mask these values by simply giving the complete 111, that is 225. If you add all these points for 8 bytes and with all the decimal numbers from 128 to this 1, you will get 128, 64, 32. All this, when you add, you will get something as in 225. So this is called the masking bit. Okay, so once you add this masking number, now perform the XOR operation. So far we learned about this, what is XOR, how you can perform this XOR. Okay, so for that, wherever the same value will be there, you need to give it 0, rest of them will be the 1. So this is 1, this is 1, again this will be 1, 1, 1, because 0 and 1, 1, 1, 1 will be 0. 0 1 1 and 1 0 will be 0. So if you understand this, this is what the XOR you get. Okay, as this number is actually belonging to this range only, because this is 5 is which is within this 8421 concept, which is less than 15, right, in total if you do here. So this number which is higher bit, so we are working actually in the lower bits, and these are the higher bits. So as you did this XOR operation, you can have this number. Now next step you have to do is to left shift by adding 1 over here, one place but by 1, adding here not 0, but you need to add here uh, 1. Okay, so how you can perform, you will see these numbers which are actually a very higher number, and anything like this will be defined something as minus, because they are the negative. In binary, we need to understand when anything which is higher bit is 1, it stands for a negative number, and if anything is in 0, that would be a positive number. So right now in this case, how you can have here, once you do the left shift by placing 1 over here, so this number would be 1. So this 0 will change its position and move it to 1 position as in left side, and this will become 0. this position will now become 1 and this becomes 0. So what about this? This will be changed to this place. So the point is, if you consider, then this actually number gets out, which is actually defining that something which is negative in number. And if you make this number in total, it will give you 4, 0, and this will be 1, which is actually a 5. So after doing this, you simply just have to add one more number here, and that is what it gives you, 6, because 4 plus 1, which is equal to, um, let me clearly mention here, this defined for 4 and this one is defining for 1. So when you add this in total, it will give you 5, and as it gives you 5, now the next step is to give it one more 1 over here, and in total you will have 6, but as in minus 6, the negative, because of this signed number. That's why you are getting this not as in minus 6. But the overall point of understanding this this not as operator, which is work as the inverter. So whatever the number is, you just simply have to change it and flip it to the number. So let's just give it in short. Let's say if any number which is equal to 10 would always be in 8 as 1, 0, for 4, 1, 0, that is equal to what? 10 in binary. But once you flip this number, it will give you as in 0, 1, 0, 1. But after this, add one more here, and in total it will give you 11. Okay, so your number, so exactly my point is, you just have to add that number, which will give you here 11. But because this is the sign value, which is the negative out here, 1 has been added, that's why it will give you minus 11. If you want to clear, just write here x is equal to 10. Now run this cell, it will give you minus 11. How it works? Once you need to flip this value, wherever 1, it will be converted to 0, and 0 becomes 1, and after that add one more here. So the point is, whatever the value, just adding a 1 here, it will generate minus 11. So that's how you can perform the not operator here, which is simple and straightforward. Don't go with all those calculation, but simply straightforward, any number and just give it sign number. I hope you like this video. If you really like, then do like, share and subscribe to my channel, and for more such videos, please hit on the bell icon. I'll see you on the next video.